So today we're going to continue our conversation on proportional relationships, only we are going to be solving word problems today. So yesterday we learned how to use cross products to solve a proportion. Today we're going to learn how to first write the proportion and then solve it. We're going to be using unit rates to write our equations, or to write our proportions that contain a variable this time, and solve for the unknown to figure out lots of different things like how many cups of flour I might need or how much a certain number of gallons of gas cost. So let's get into some review to start. All right, just a reminder from the last lesson, a proportion is an equation stating that two ratios or rates are equivalent. We know that 6/8 and 3/4 create a proportion. We also know that we could check that using their cross products like we learned yesterday. Okay, so that if I were to cross multiply going up, 8 times 3, that's 24. 4 times 6, that's 24. Now yesterday you saw me do my cross products like this. Let's put this down again. So yesterday I did my cross products going this way and that way, and I had 24 and 24. Notice how this 24 is the same as that 24 is the same as that one and that one. So either way you see it, both are showing cross products, both are showing the same thing. You might see some people write it this way, you might see some others write it this way. I learned it this way when I was in school, but now this is one of the more common ways that's used. So neither way is wrong, but if you do see it this other way here, I want you to be aware of what I am talking about. All right, let's try an example. So a recipe serves 8 people and calls for 3 cups of flour. If you want to make the recipe for 14 people, about how many cups of flour should you use? So I know I'm talking about a rate here, and my rate is going to be cups of flour per people served for this particular recipe. Okay, so let's get some given information. I'm given that 3 cups of flour makes enough for 8 people in this recipe. I'm trying to figure out how much makes enough for 14 people. Okay, so I want to know how much flour, right? How much cups of flour is going to make enough of this particular recipe for 14 people. So in this case, we have an unknown value. And that unknown value I'm going to represent with a variable, let's call it C, is going to be equal to the cups of flour for 14 people. So now I'm going to take us back to that rate that we had set up at the top right-hand corner at the beginning. So in any recipe, if you want to increase the recipe and make it for more people, you want the recipe to stay proportional to the original recipe. So for example, if I'm making a recipe that calls for 12 chocolate chips, and those 12 chocolate chips work for 2 people, in order to make that recipe for 4 people, I'm going to want to increase that to 24 chocolate chips so it tastes just as good. So in this case, we have cups per people, and we're going to want that to equal to cups for people. So I know that in this particular case, our recipe calls for 3 cups of flour for every 8 people. So if I want to make that same recipe and I want to make it taste good for 14 people, that means that I need to know what will create a proportion that would keep my recipe equivalent to the original recipe. So I set up a proportion of 3/8 should be equal to C over 14, and I can set out to solve that in order to figure out what would make this ratio here equal to this ratio here. So I am telling you now that these two ratios are in proportion, they're equal. We've set them up that way so that we could figure out how to make this recipe equally delicious. So let's cross multiply. I know going up this arrow I'm going to have 8C. And going down this arrow, I'm going to have 3 times 14, which is 42. Now, according to what we learned yesterday, if two ratios are proportional to one another, then their cross products should be equal. So in order for these two recipes to taste just the same, 8C has to be equal to 42. So we solved a bunch of these yesterday, and we know that in order to figure out what's going on here, to undo what's being done to the variable C, C is being multiplied by 8, so I need to divide by 8 on each side. Now, I'm going to get a decimal answer here, and you are going to be allowed to use a calculator for these kinds of problems. So let's grab our calculator, and let's do 42 divided by 8. Oop, I'm going to clear out my calculator because I hit the wrong button. 42 divided by 8. Be careful when you use the calculator to watch what you're punching in, because if you punch in blindly and you don't look at what you're punching in, you could get the wrong answer and then trust the calculator but have the wrong answer. So I get 5.25, which means that I need 5 1/4 cups of flour to make my recipe taste the same for 14 people. Now, it is okay for me to say that 3 over 8 is equal to 5.25 out of 14. I know in the past we haven't really talked about fractions that have decimals in either the numerator or denominator, but these are ratios. So these values mean something. This is 3 cups for 8 people. This is 5.25 cups for 14 people. So these numbers mean something. It's okay if they're decimal values. All right, let's try another problem. Melvin purchased 8 t-shirts for $64. We want to write an equation, or in this case, instead of an equation, I'm going to take this out, we're going to write a proportion. Okay, so we want to write a proportion relating the cost to the number of t-shirts. How much would it cost to purchase 10 t-shirts? So in this case, the piece of information that we don't know is how much it costs for 10 t-shirts. All right, I know that 8 shirts costs $64, but I don't know how much 10 shirts cost. So I'm going to say that my variable, let's call it S, okay, equals the amount of money for 10 shirts. Now, what variable you choose doesn't really matter. You could pick X, Y, A, B, C, D. Doesn't really matter. So it's just a variable to represent a value that you don't know. So in this case, I know that I'm going to look at the rate of shirts, $2. And in either case, shirts to dollars should be equal to shirts to dollars. So in this case, let's say that 8 over 64 is equal to, well, again, I know 10 shirts. So this time, my 10 is actually going to go in the numerator because it's going to go shirts, shirts, shirts to dollars, and I'm going to have S in the denominator because I do not know how many dollars those 10 shirts are going to cost. So we're going to cross multiply. I'm going to get that 64 times 10 is 640. I hope you didn't pull out your calculator for that. That's too easy to use a calculator for. And 8 times S is going to be 8S. So in order for these two proportions to be equal to each other, 8S has to be equal to 640. Did I say proportions? So in order for these two ratios to be equivalent and this proportion to be true, then 8S, their cross products, have to be equal. 8S has to be equal to 640. So in order to undo what's being done to our variable S, I'm going to divide by 8 on each side. And I'm going to get that S is equal to $80. So it's $80 for 10 shirts. So proportions are actually very useful. And a little bit later in class this week, we are going to be doing a proportional fun activity, which is going to allow us to do some real life proportion use type situations. So this is one of those lessons that I really want you to focus on so we can apply it to some real life situations and have some fun doing a lab with this. All right, here's the last example before I give you the problem of the day. All right, so JC bought 8 gallons of gas for $31.12. Write an equation relating the cost C to the number of gallons G of gas. How much would JC pay for 11 gallons at the same rate? Now, in this particular situation, you were given one variable that you're not going to need to use. They gave you two variables, but one of them is actually an arbitrary variable that you're not really going to need to use. So the question asks, how much would JC pay for 11 gallons at the same rate? I already know the 11 gallons, so I actually don't need this right here. So the one that I am going to need is C. So in setting up this problem, I know that 8 gallons costs $31.12. And I know that I am looking to purchase 11 gallons, but I don't know how much that's going to cost. They gave us our variable in this situation. They said C is equal to the cost. Okay, so let's get a proportion set up. I'm going to stop talking for about 10 seconds to let you have a head start. Pause if you need to. All right, so I know that 8 gallons costs $31.12, and I'm looking to purchase 11 gallons, but I don't know how much that costs. So since I've set up my two equivalent ratios, I need to use cross products to find out what that unknown value is. So 31.12 times 11, if you want it this time, you could use a calculator. So 31.12 times 11, that's going to be $342.32. And I know that 8 times C is going to be 8C. I'm going to change colors just so things are a little clearer to look at. So my equation is 8C is equal to 342.32. So in order to undo what's being done to my variable, I'm going to divide by 8 on each side, giving me that the cost is equal to, so if you still have your calculator out, you can divide that by 8, $42.79. For 11 gallons of gas. All right, so let's move into our problem of the day. Tomorrow you'll be expected to set this up and solve it at the beginning of the period. All right, I want you to be careful of two things. All right, the first thing is that they're asking you first how much Trina would earn tutoring for 2 hours, and then the second thing is they also want you to solve for 4 hours. So you're actually going to have, for tomorrow's class, 2 proportions. Okay, I'm going to abbreviate with proportion that way. All right, and then you're also going to have 2 answers. All right, so it's kind of like solving 2 problems. All right, good luck, and I'll see you tomorrow.